So in the next segment of the class, we'll talk extensively about what's called the decoding problem in phrase-based models. But firstly, I just want to give you a sketch of how the phrase-based model can be used in translation. So for this, I'm going to use a particular example where we have some German string, and we're going to see that we produce the English translation of this, basically left to right. We build up the translation left to right on the English side. And as we build up the translation left to right, we're going to incorporate various scores indicating how plausible this particular translation is. And in particular, there are going to be three types of scores. Firstly, a language modeling score. Secondly, a phrase model score using these phrase parameters T that I showed you earlier. And finally, a distortion model, which I'll describe in more detail as we go. So the basic idea in translating this German sentence is going to be to try to find a sequence of phrases where we can translate at each point one or more German words into one or more English words and thereby build a translation left to right. Okay? So in the first step, we might say, oh, let's translate this word heute as today because I have some phrasal entry which says that these two things are a possible translation of each other. Now, this particular move, this particular choice, is going to have an associated probability or cost. We're going to have some language model scores, Q. So this is the language model. And this is going to allow us to give a prior probability for how likely the English string is that we're building. This would typically be a trigram language model. And then we're going to have some translation model scores, which are going to be the T parameters I showed you earlier. And they're going to reflect, for example, how likely today is to be translated as heute. And then finally, we're going to have some ADA parameters, which are going to be what are called distortion parameters, and which are going to penalize us from skipping over large sequences of German words. They're going to try to enforce the constraint that the word orders in the two languages are somewhat related to each other. We'll talk a lot about this as we go forward in the class. So I could multiply these Q and T parameters together, and I could search over all possible translations and try to find the maximum translation under this score, but actually it's a little more convenient to sum the log parameters. So we're going to take the sum of log Q plus log T plus, then we'll see this ADA term. Okay, so this particular move is going to have a language model score. Firstly, we have the probability of today under a trigram language model. So this Q parameter is going to be a trigram parameter. What's the probability of today, given that we have these two start symbols? These are just the same old start symbols we've seen from language models in the very first lecture of this class. Secondly, we have a probability of generating the word heute, given today. And finally, this is going to be some cost penalizing the number of words we skip over. Now, because both of these phrases are at the very start of the sentence, we define the number of words that we've skipped over to be 0. ADA is going to be some parameter. It's typically negative. It might be -2, for example, which is going to penalize cases where we skip over large numbers of words. And this is going to be the only control we have over differing word order of these two languages. It's extremely crude. It makes little sense linguistically, but it does give you some control over word order. As I said, we'll talk later in the class about how to improve upon this, but this is how we'll start. So that's the first step to make this translation. So in the second step of the translation, we might choose the following phrase. So we might see that we have this German sequence of words translated as we shall be. Sorry, this should be we shall be. And again, we see language model scores, we see phrase model scores, and distortion model scores. So the language model score, again, we're using a trigram language model. We have the probability of we given star today. Those are the two previous words here. We have the probability of shall given we and today. And finally, we have the probability of be given we and shall. So one Q parameter for each of the English words that we've chosen. On the phrase model side, we have log of T of this German string, werden wir, given this English substring, we shall be. And finally, we have a distortion cost. And again, notice that in doing this, we haven't skipped over any German words. We've chosen the next phrase completely adjacent to heute, which is the current translation. Sorry, the current translation has translated heute, and the next phrase is adjacent to this, and so we've skipped over 0 words, and so this cost is 0. So here's the next step of the translation. We've decided to use a phrase entry which says that this word in German, which is seen right here at the end of the sentence, corresponds to the word debating in English. And so we can make this translation step, again building up another word in the English translation. We again have 3 scores: a language model score, phrase-based model score, and a distortion model score. The language model score is simply a single term because we have a single word being generated. The probability of debating, given that the previous 2 words are shall and be. The phrase model score says what's the probability of this German word conditioned on the fact that we have the English word debating. And then finally we have something more interesting going on in the distortion model here. So remember that eta is again going to be some negative value, say -2, which is used to discourage long-range reorderings in these models. And we have 6 here, and that's because I have skipped over 1, 2, 3, 4, 5, 6 words. And so this would incur a cost of -2 times 6. This would be -12. So that's a fairly heavy penalty in this case for skipping over several words. And this process will continue, so maybe at the next step we'll choose these 3 German words to be translated as the reopening. And again, this is going to have a language model score, a phrase-based model score, and a distortion score. And then finally, we might translate this German sequence as the English sequence of the Mont Blanc Tunnel. So the final translation is: today we shall be debating the reopening of the Mont Blanc Tunnel. And we've done this using a sequence of phrases. Firstly, we had today. Then we had, I think, we shall be, and then debating, and then the reopening, and of the Mont Blanc Tunnel. And we've basically derived these phrases using our phrasal lexicon, and we've ordered these phrases in some ordering left to right. So that's just a sketch. In the next lecture, we will go into considerable depth of how we actually decode with these translation models. But this is the basic process. A translation is going to involve picking a sequence of phrases like this. Each choice is going to involve a language modeling score, a phrase score, and a distortion score. And we're actually going to try to search over the space of all possible translations. We're going to search for the translation with the highest score under the combination of these 3 parameter types.